Good evening. My name is Renee Miles, and I'm going to explain um, a calculus problem um, taken from question number 5 from our week 1 practice quiz. Um, this function is 1 over x minus 1. This is the limit as the limit of x goes to 1. So this is the function 1 over x minus 1 taken to the limit as x approaches 1 from each side. Excuse me. I provided a graph. Um, and I get my pencil. Okay. On this graph, red, I don't know if you can see it, red is x equals 1. X equals 1. That's what we're taking the limit to. That's the red dash right here. And the function is the blue dotted line. Blue dots. Yes. This is as x approaches 1 from the negative side. And then this one is it's 1 as it approaches 1, as x approaches 1 from the positive side. We can determine that the limit does not exist in two ways here. One is by looking at the graph, and the other is by solving the function. Solve the function for x as x approaches 1. Um, so let's look at the graph. And as you approach from the right, yes, approach from the right, the function gets close to 0. It gets close to 1, but it never gets to 1. And it goes to infinity positive. As you approach from the left, right side, it also approaches 1, but it never reaches 1. It goes to infinity in the negative. Um, so there is no limit. They both they both go to infinity, and I hope that was um, elementary enough. Oh, and the other way to look for the limit and to see that there is no limit is solve the function as x approaches 1 from both the right and the left. In each case, though, the denominator um, becomes very, very small because the denominator is x minus 1. and it gets really small. Consequently, the function becomes infinitely large, but it becomes infinitely large in the negative direction and infinitely large in the positive direction. Excuse me. Subsequently, again, there is no limit. Thus answers the lesson and the limit. Um, I hope that made sense. Thank you for letting me do this and having an opportunity to get on the right track. Have a good evening. Bye.